My mom enrolled me in one of them. Said like.
Do you like it?
It's hard.
So my mom switched me to a self-paced one.
Oh.
Yeah. Like I was going to have one 15 minutes ago, but I realized it was all text.
Oof. Okay. All right. Little warm up, quickie. Little quickie. Why is my channel open? Give me a second, guys. Hold on 1 second. It's not working. Oh, there you go. Okay, let's go again. There you go. All right, my chat just doesn't want to open. We'll see. All right, just do these real fast and then just tell me the answers and we're good. Just type the answers to me. I give us a few minutes. But yeah, what was I gonna say? Oh yeah. So yeah, the new Mulan, it just doesn't stand up to the original, obviously. I'm really upset that not upset, but disappointed that they got rid of Mushu, because Mushu was pretty integral to the plot of the original one. Like that's where the source of motivation, most of Mulan's motivation comes from, is from Mushu and her dad, her father, and her own self-determination. So them getting rid of Mushu, in my opinion, was just a killer for me. I was like, I don't like this.
Hi, quick question, but why is there a comma on questions 2 and 3?
It's to tell you that x squared equals 2.5. If you are skilled enough, you don't have to know x, because x squared you already know. So you can just plug in 2.5 for x squared, because that's what it is. It's just a little thing, because yeah.
Oh, that was kind of confusing.
Yeah. You simply plug it in, because that's how variables work. If they give you, like if you said x is x plus 1.
Like x squared is 2.5? Oh,
yeah. Okay. No, x squared is equal to 2.5, right? So you just simply plug it in 2.5 for x squared, because you already have the x squared here. Okay. Yeah. It's like a simple trick. Like say if you had x equals x plus 1, you don't have to solve for this. You can just use this new x and just plug in 4x plus 1, right? And this is totally legit because they told you x equals x plus 1. That's just a little trick. That's how you manipulate variables. But the Lion King, it was all right for me. I kind of liked it. But Mulan is a no-go for me. I was like, okay, whatever. Lion King was okay though. I liked it, the live action one. And there's no general shot. Yeah, that's true. In Mulan Real. Who's Mushu? Is he a mushroom? No, Mushu is a dragon in the original. Sorry, I didn't catch the question. He is a no. We don't have Kahu as well. Sorry. Mushu is a dragon in the original movie who is like her companion. Yes, a sassy dragon, and he's Mulan's companion throughout the entire movie. And basically, without him, in my opinion, Mulan wouldn't do the things that she did in the original movie. Like all the heroic things she did. And he just adds the comedic detail to it. A depromoted Zodiac? Yeah, depromoted, yeah. Demoted? No, depromoted. Demoted. That's the word. But like he's a very important demoted. D-E-M-O-T-E-D. That's depromote. That's what there's no depromoted. That's not a word. It's called demoted. Demote. Does dot mean times? Yes. There's a dot. Weird spelling. All right, so first one, you just distribute out the 1/2, or you could if you wanted to. or just multiply by 2, multiply the whole thing by 2. This will cancel out. This becomes 40. So 6k plus 4 equals 40. And then you solve and k equals 6. This one, because 40 minus 4 is 36, and the 36 divided by 6 is 6. So that's for that one. This one you just plug in 14 for w. That's what the comma is. This one plug in 2.5 for x squared. This one is 1/4. X equals 1/4. Just divide by 44. This one you can, little trick, divide everything by 100. This will go away. This will go away. These two will go away. These two will go away. So you get 900 equals x plus 10. So x equals 890. So yeah. Pretty, why is my chat not showing? Pretty simple stuff. Yep. Alrighty. So there you go. Here are the answers. There should be 1/4. Whoops. Right? Yeah. 1/4. I guess Power 1 really doesn't like when I write fractions. I remember the 1. So yep. Okay. Let's get to the lesson. Give me 1 second. There you go. All right. So independent variable. So a variable whose value determines the value of another quantity. That's not very helpful, but you'll see what I mean. And in an experiment, it's a variable being manipulated. So what I mean by that is if you're doing like a scientific experiment, usually you have two variables, a dependent variable, independent variable. And the independent variable is the one that you manipulate. It's the one that you look to see, hey, if I change this variable, how does this change this other thing, right? See it in that way. Most common independent variables usually time. So like years, hours, minutes, days, all that kind of stuff. So like say like plant growth, right? If you say like how much will a certain plant grow in inches in a certain amount of time, and so you manipulate the time. You see like, okay, how about 10 minutes or 10 days, 12 days, 14 days? That's your independent variable. You're manipulating it to see how much a plant will grow in terms of inches. Plant. Okay, so a dependent variable is a variable who depends on the value of another quantity. It's in the word dependent. Once again, not very helpful. Just know that independent variable drives the dependent variable. These emotes. And it's usually in a rate. It's you guys remember that? It's usually the first value. So for example, miles per hour, miles would be your dependent variable and the hours would be your independent variable, because the hours depends on how many miles you travel. The amount of miles you travel, sorry, depends on how many hours you've traveled. You know what I mean? And as a rule of thumb, when you graph independent, dependent variables, the x-axis will have the independent variable on it, and the y-axis will have the dependent variable. All right, so an example. In a game, a person must try and destroy as many ships as possible. Each ship destroyed provides 10 points to the player. S, so the variable S, represents the number of ships the player destroys, and P, variable P, represents the amount of points they score. This relationship can be written as an equation, P equals 10S. So you get how many points is dependent on how many ships you kill or destroy. So are the following statements true or false? Oh my God, what is this spelling, Jenny? S is independent. But yeah. I know what you mean. I know what you mean. Yeah, it's pretty simple stuff. This is just fancy terms for y and x. Two false. Yeah. Number 2 is indeed false. Nice job. 1 is true. Yes. See, I know that word, Yeti. Yeah. Yes, I know that word. I'm very familiar with that word. 5. The amount of ships destroyed goes on the x-axis, and the amount of points earned goes on the y-axis. Well, if the amount of ships destroyed is the dependent variable, and I just said that dependent variable goes on the y-axis, it would be false. So yes, number 5 is false. I know Alien, like Alien versus Predator Alien. I do. Oh wait, no. Number 5 is true actually. I meant to say that. Whoops. You'll see why. I'll explain it. The next slide. Yeah, number 5 is true. So the amount of ships you destroy is independent and the amount of points you get because you manipulate the amount of ships you destroy, and that gives you how many points, different variable amount of points per. You'll see what I mean if I don't know. Okay, so S is independent and P is dependent. Why? Because the amount of points you get depends on how many ships you destroy. Right? If you think about it logically, that would make sense, right? Because it depends on how many points you get. It depends on how many ships you destroy in this game, rather in this problem. So the amount of ships destroyed goes on the x-axis would be true because remember, independent variables go on the x-axis and dependent variables go on the y-axis. So amount of points earned goes on the y-axis. So yeah, number 5 is true. Because the number of ships I destroy or you destroy. Yeah, think about it. Okay, so you're playing the game, right? And someone asks you, okay, how many points do you think you can get? And you can say, it depends on how many ships I destroy, because you get 10 points per ship destroyed, right? Does not matter. Because the number of ships you destroy does not matter. In what context does it not matter? It does matter in trying to see how many points you get. So the points is dependent on how many ships you destroy. That's what I'm trying to get you guys to think about. And think about it logically, like, it's hard to spin it the other way. Why are you giving all these special symbols, Jenny? That's scaring me. Okay. So only number 2 is false. So number 1 is true because you plug in 4 and you get 10 times 4. False, the game gives you a score depending on how many ships you destroy. So like I said, the amount of points you get depends on how many ships you destroy. Number 3 is true. I just said that. I said the reason why. 4, the number of points you score is driven how many ships you destroyed. Also said the same thing. And then 5, yeah, same thing. Remember, independent variable x-axis, dependent variable y-axis. Just remember that. Okay. What's this? Oh yeah. Okay. So let's learn how to take a word problem and just model it. Turn it into expression or an equation using variables that they ask for. Because this is really common in American curriculum. Personally, it's not that important, but it is pretty important at the same time. The best way to learn this is through practice and intuition, which is just knowledge and experience. And so there's no real way to do set in stone. Pieces depend on yeah, that's exactly right. All right, so here's for pointers. If it has an initial value, the question, that usually would be added or subtracted. What is going on, Jenny? What is this? Okay. So example, if Aaron makes $30 an hour and he starts with $100 in his pocket, and you write an expression showing how much money Aaron will make after H hours, you would put 30H, because $30 per hour, plus 100, and notice the plus 100. This is the initial value I'm talking about, because he starts with $100, right? It shows how much money he has at the end. Shook face. And then when you graph, it's something called the Y-intercept, which I don't know if you guys know about, but we can talk about that later. Usually it's pretty obvious to see which is dependent and independent variable. Sometimes it's not. Most of the time it's up to logic, like I said. So example, John uses 15 ounces of paint per paint bucket. So which one's the independent variable? Is it the paint buckets or the ounces of paint? Well, the paint buckets would be independent because how much paint you use depends on how many ounces of paints rather, depends on how many paint buckets you use, John uses. You can use how many paint buckets you ever want. That's independent of everything. That's your own free choice, But the amount of paint you use at the end of the day depends on how many buckets. And then lastly, formulas actually help you figure out. Most common formula you should know is distance equals rate times time. You should always know that. So miles equals miles per hour. No, rate times time. Okay, that's a bad example actually. Should be distance equals rate times time. Miles. Oh yeah. Okay, yeah, miles equals miles per hour times hour, right? Distance is rate, miles per hour is your rate times time, and the hours cancel. So that's how you get that. So you should know D equals R times T. This is very common. You should know this. And then if you rearrange it, you can get rate is distance over time, which makes sense because miles per hour, miles divided by hour. Time is distance divided by rate because the miles will cancel when you put this together and you left with time. So yeah, know this equation. D equals R times T. Distance equals rate times time. Very important. And you'll learn in physics in high school and other stuff like delta x equals initial velocity times time. This is the same exact thing. Your velocity is your rate, time is your time, delta x is your distance. Delta x means change in x because change in your x value on the xy plane. Okay. All right, here's some practice. You guys a little bit do it. I'll read out each of it and see what you guys think. So Kyle is planning to start his own garden. He goes to the store and sees that seeds cost $2 for each packet and fertilizer costs $10 for each bag. On top of that, there is, I'll get to your question later, Cindy. Hold on. On top of that, there is a lump sum, so a one-time tax of $350. Remember, we're talking about initial value. Write an expression showing how much money Kyle will spend if he buys S packets of seeds and F bags of fertilizer. So give you guys a little bit to figure that out. Okay, so how many different formulas are there and for what? There's tons of formulas. Scientific formulas, there's a bunch of mathematical formulas. For every situation, I mean, there's formulas for area, there's formulas for volume, there's formulas for arc length. Oops, I mean the speed and distance one. Oh, there's only three then. Technically, there's only three. Because D equals R times T, and you just rearrange it. There's only three. Then you rearrange it so you get R equals D over T, and you get T equals D divided by R. There's only three. This is the staple for distance and time and all that stuff. You can't solve it? Okay. You have the right idea, Zoe, but that's not an expression. I'll let you guys give you guys a few more minutes, but I'll tell you guys why, like the answer. But you got the right idea of the 2s and 10f. But it's not going to equal x because it's not an equation. It's only an expression. All right. Okay, so you know that seeds are S, right? And it costs $2. Can I explain? Okay. So seeds are $2 each, right? So you have 2S because we're trying to see how much money he will spend, right? So 2S for how much money he spends on seeds, how many packets of seeds, plus the 10F because it's $10 per bag of fertilizer, right? And then on top of that, when you pay for any product, assume when he pays for any product, even if he pays for no product, he gets a one-time tax of $350. So it would be 2S plus 10F plus $350. $350 is your initial condition because the one-time tax. So I hope you guys get that. All right, number 2. Jaden is saving money for a new phone. Costs $120. That's pretty inexpensive, I'm not gonna lie. So it must be like one of those flip phones. I don't know. Cheap. Do you guys even know what a flip phone is? Oh my God. Okay, so I don't know if you guys, yeah, you do? Okay, good job, Jenny. That's nice. So for those of you that don't know what a flip phone is, before there were smartphones and iPhones and touchscreens, you actually would flip the lid. You would flip it. You had one, quote unquote. You would flip it, right? And you had to, yeah, it's the one with the lid. Yes, a flip phone is the one with the lid that opens up. Yeah, so you would flip it open. It's almost like a lid, and then you wouldn't touch the screen. You'd press buttons. It's actually your mom's. Yeah. Only old people, even old people use iPhones now, or not iPhones, touchscreen phones now. I still have my old flip phone at home, or not home, right, with me in my drawer somewhere. So yeah. Okay. So he starts with $25, and each week he saves $5. Yeah, mine is broken too, my flip phone. So I want you to write and solve an equation that will show how many weeks W it will take to buy the new phone. Broke like 5 years ago. Oof. So yeah, if your goal is 120, and this is gonna be an equation, remember? So your goal is 120, and it starts with $25. So 25 will go in the front. This is positive 25. And each week he saves $5. So he would add on 5 per week, use W. And when you solve for W, you would get, let me do this real quick. 19, W equals 19. So it would take Jaden 19 weeks to get this new phone, assuming that he saves up $5 per thingy, per month, per week. Pretty easy stuff. 120 divided by 25. You're not dividing by 25, though. No. C minus S minus, oh my God, how many W's is that? 1, 2, times W, whoa, 1, 2, whoa. About 5. Are you talking about number 2? I'm getting spammed with 5 now. I'm getting spammed with 5. Yeah, that's basically, that works in the, yeah. You're basically solving for W. Same thing. All right, number 3. Cheryl is filling up bags for a party. She puts 2 keychains and 7 treats in each bag. That's a lot.
Put more treats.
Treats? What? What's on the treats? What?
Put more treats.
Put more treats?
Yes.
45W times. I could actually solve that, but I'm not gonna do that. I could solve that actually though. 50,000 treats. All right. Anyways, what was I? She puts 2 keychains and 7 treats in each bag. Why 2 keychains? I got this online. Write an expression that shows how many total keychains K and how treats T she'll need to put up for the amount B bag she fills up. I don't think you'll need this because you only make expression. Because this will just be simply 2K plus 7T. Let's see, I forgot what I put for my answer. 9B. Right expression shows how many total keychains K and maybe it should be an equation because then each B would be that. Each B would be 2K and 7T, which is this whole stuff inside. We'll see. Yeah, I don't know. I don't like this question. All right, number 4. This is easy. I see a lot of you guys did it. Sergey has 12 more books than Bratislav. If Bratislav has B books, write an expression showing how many books Sergey has. Well, more books just means addition. So 12 plus B, or B plus 12. This is more common, B plus 12. So yeah, that's basically a little bit of practice. If you guys have never seen it, well, here's a little primer. Seen word problems like this? A little primer. Oh my God, is that balanced? That's not balanced. This guy's dashing all over the place. Okay. So here's the answers. 2P plus 10F is 350 because 10F for each fertilizer, 2P for each seed packet, and plus the lump sum tax, 350. The phone costs 120, so you just do 120 equals 25 plus 5W, and you solve for W by subtracting 25. So be 95 equals 5W, and then W equals 17. You divide 5, you get W equals 7 or 19. Whoops, 19 weeks. Okay. What is this? What? 12 plus B works. Yeah, 12 plus B works. That's fine. It's more common in B plus 12. What is this, Zoe? W times W grouped together. Okay, so this is what Zoe typed to me. Plus ... It's like ... means the same exact thing appears over and over again. Equals M. Equals M. What am I supposed to do with this? What am I supposed to do with this? What am I supposed to do with this problem? You want to find out what m is? Because m is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. XD, you won't do anything with it. That is indeed an XD moment. An XD moment. Erases it. Yes. I will indeed erase it. Get out of here. Okay. All right. So each bag will have 2K keychains and 70 treats. We're looking for a total, so we add them up. Then we multiply by B for amount of bags. Oh, I see what I see. So if you have like 2 bags, you would just distribute the 2 out. Yeah, okay, that makes sense. Okay, so 2KB plus 70B. I don't like that question, but that makes sense. If you have 3 bags, you
I
distribute it
have
out.
a question.
Yep. Go ahead.
If it has 2K keychains and 70 treats. Okay, I read the question wrong, but if you go back to the question on the last side,
Yep.
the question's like it's written. Cheryl is filling up bags for a party. She puts 2 keychains
I erase this.
and 7 treats in each bag.
Yep.
Write an expression that shows how many total keychains K and treats T she will need to put for the amount of B bag she fills up. Technically, since there's 2 keychains and 7 treats in each bag, there's 9 items in each bag. Technically, if you put it like that, that's 2 keychains, 2 keychains times B. 7.
Oh, I
treats
see what you mean.
B.
Yeah, I see what you mean.
So altogether, it'd technically be 9 items,
Yeah.
but they're asking for separates.
Yeah, like I said, I don't like this question. I see what you
I
mean
don't
though.
like it either.
That could work because you just look at the keychains and treats as one thing together, and you just combine like terms. That makes sense logically from a logical standpoint. Yeah. My question is, why the hell is Cheryl? Oh, that's a bad word. Why the heck is Cheryl putting up so much stuff in each bag? Like, who needs keychains? Everyone only wants treats.
Keychains are kind of useless, to be
Yeah,
honest.
keychains.
Treats are better. Give us all the candy. Peasant.
What type of did she put in the bag? Like dog treats or something?
Dog treats. Treat train. Wait, so were you asking Jenny 2K? Oh yeah. Don't worry about that. Yeah, I don't like this question. I just don't like it. Let's move on. Okay. And then the last one I already told you, 12 plus B or B plus 12, B plus 12. I think B plus 12 is more common, but either way works because a lot of people like putting the variable first. I don't know why, but either way works. All right. Writing inequality. So it's the same thing. So it's much like writing an equation from the word problems. Biggest difference is obviously you choose which inequality sign to use based on the words or information you're given. And the best way to look for keywords. So here's a few keywords that I usually encountered when I was a kid doing this. At least is either less than or equal to usually, because when we say at least a certain amount, less than or equal to. At most, greater than or equal to, because you want most, so you can go over it. At least you can go under it, but you can't go over it. Wait a minute. Okay, yeah. Less than and greater than might show up, like just straight up say less than and greater
At
than.
least.
I feel like at least should be greater than. I forgot. At least. Yeah,
Wait,
at least
I
should
have
be
a
greater than.
question.
Yeah, go ahead.
I have another question, but in those classes when you're using inequalities in classes, most people don't use the at most. People just typically use greater than or equal to. Can you explain why, or can you at least give a reason?
What do you mean? So like just the problems just straight up say, hey, greater than or equal to.
Yes, they don't even say at most.
Oh, that's just whoever made the questions just did that. And inequality, yeah, I don't have an answer for that. Hey, ask the person. Yeah, no reason. Yeah, no reason with the mocking English.
It's a
No
good
reason.
idea.
Yeah, I just ask the person who made the question. Word problems, in my opinion, are something else. Word problems I don't like. What does inequality means? So inequality is a comparison of 2 expressions with that either say it's less than or greater than. It says something that 2 things are not equal to each other, right? So it's not an equation because you don't say equals to. So you would either say less than or equal to, I mean, less than, greater than, say less than or equal to, greater than or equal to. So it's a comparison between two expressions without an equal sign. Do you want to see my face? Do you? Yeah, go ahead. I mean, by all means. Don't, I'm not gonna stop you. No? Okay. I'm not gonna stop you. Okay. So yeah, at most, I think at least is actually greater than or equal. I messed this up. I think swap these two. Because at most, yeah, at most is less than or equal to. And this is greater than. So at least is greater than or equal to, and at most is less than or equal to. My bad. I messed that up. Less than and greater than, just straight up, we'll know less than, greater than. Highest and lowest might give some clues. They indicate less than or equal to and greater than or equal to respectively. So the highest amount, the lowest amount, something. Over and under is also sometimes, I've seen that before as a child. I didn't like those because usually greater than and less than, but not equal to. And usually I put equal to on accident. So over and under, that makes sense, you know. You have to be over, you know, this limit. You cannot be equal. You have to be over. Okay. So write an equation, expression, inequality based on the information you are given. So number one, forest fires usually occur at temperatures over 60 degrees Fahrenheit. Speaking of which, we have a bunch of forest fires in the west coast of the US. Write an inequality showing at what temperatures T, forest fires begin in degrees Fahrenheit. This is actually a really low temperature, but yeah, it's actually true. Forest fires don't take that much to start. You just have to be dry enough, and
there has to be fuel for it.
Yeah. No, it doesn't have to be. It could be, yeah, actually, yeah. Lightning storms,
Yeah.
matches.
Human ignorance.
Human ignorance, that's true.
You could say that.
You could say that.
It could also be like the cause of the accidental dropping of leaves somewhere, and then a storm happens to take place. Lightning, bam, fire occurs.
Yep. Have you guys heard of Smokey the Bear? You guys know Smokey the Bear? I don't know if you guys are old enough for that.
Yes.
Smokey the Bear? Only you can prevent forest fires. So Smokey the Bear is a bear, obviously, a bear mascot that tries to prevent forest fires by like telling you not to use matches and stuff like that, because matches are pretty common in forest fires and just fires in general. Just don't use matches, guys. Like,
I think I have an eraser with Smokey the Bear on it.
Nice. I thought they stopped showing him because I haven't seen him in a while, and he's pretty old. Like, he was in the 90s, 80s and 90s. All right. I was born in 2002, so I know all this stuff anyways, because I actually like the old stuff more than the new stuff. I know. Zoomer humor, guys. Yeah, I don't like Zoomer humor. I'm not gonna lie. I don't like Boomer humor either, but I hate Zoomer humor. So, yeah. All right. So this one, over. You see the word over. So this would be T has to be greater than 60 degrees Fahrenheit. So
over. Wait, can it be 60 Fahrenheit?
What do you mean? Like, can it be?
Can it be 60 Fahrenheit and the forest fire starts?
No, because it says over, so you have to go over it. You can't be 60.
So we can't do it at least.
Yeah, you can't do this thing. You can't do that. You have to do over, because it says over. If it says like at least 60 degrees, then yeah, you could do that. Did you know that forest fires travel faster uphill? That makes sense. That actually makes sense. That makes a lot of sense.
Fun fact, at least 59 and over 60 is not the same.
Oh, that's true. Okay, number 2. Books from Middle Ages are at least, there's at least, 650 years old. Write an equality that shows the possible ages A in years of these books. I think I wrote the answers wrong on next slide, but so I'll just do it with you guys. Yeah, that's right. So it'll be A is less than equal to 650. Or sorry, greater. That should be greater than, right? That should be greater than. Whoops. Because it says at least 650, so it has to be at least 650. It has to be 650 or above it. I messed that one up. Yeah, equal to, greater than or equal to, yeah. Messed that up. So at least is greater than or equal to. At most is less than or equal to. Just remember that. Okay, a school is trying to plan for a field trip. For every 7 students, at least 1 adult, so just at least, must be present for them. Write in some equation that shows how many adults A, this is mixed practice, so equation, adults A are needed if there's a total of 84 students. That one you guys should be able to figure out. It's pretty simple. Some leaves drops, then the school blows up. Dang. Kind of school you go to. Oh my God. I would not want to go to that school. And this school blows up. Is like a big boom or like a small boom, you know? How big of a boom we're talking here? It's hot, so. Okay, so this one is 84 equals 7A. Okay, you can use A for adults, I guess. Yeah, A. And then
I know what A is. A is
12.
Yes.
12. Okay. All right. Jerome walks 6 dogs for his neighbors. He must walk each one for at most, what was that most? 10 minutes a day. Write inequality representing the collective total amount of time in M minutes, which he must spend walking dogs each day. I say collective amount of time because people just argue, oh, he just does 10, right? Instead of 60, because I want you guys to write 60 minutes. But it's like, oh no, he just walks dogs for 10 if he walks all of them at the same time. So I say collective total amount for each dog. So the at most would indicate less than or equal to. So you have your M, your 60 is less than, equal to. Or no, wait, this is so confusing, so I didn't like it. It should be greater than or equal to. I think almost maybe means the same thing. A nuclear boom. Is it more better? Yeah. What can we do more? I don't know. Oh my God, you guys are crazy. Nuclear booms, the mushroom cloud. Oh my God. How much you guys know about nukes? How much do you guys know about nukes? I don't like this problem. Therefore, nothing? Yes, boom, boom. Okay, so I believe the most common way to make nuclear explosions is uranium-230 what? 235, I believe, if I recall correctly. Let me see. Yeah, 235. So uranium-235 is the most common, equals MC squared. That is also, yes, equals MC squared is nuclear physics. Uranium-235 is an isotope. You don't know what isotope means, don't worry about it. Uranium is an element, basically. And what this does is it turns into U-233, I believe. And when you lose these two numbers right here, it gives off tons of energy based on this equation, E equals MC squared. C is the speed of light, by the way, which is really, really fast, like super duper fast. It's approximately 3 times 10 to the 8th meters per second. So it's super fast. And basically, when U-235 decays naturally, because 235 is unstable, it decays naturally to 233, I believe. I think 233 or 232 or something like that. It gives off lots of energy. And imagine that with billions of atoms, right? All that energy at one time, U-235 just splitting off to U-233 into billions of atoms at one time. That's a ton of energy in one nuclear warhead and one missile, right? Like a missile, right? That kind of thing. This will go out. Imagine this much energy stored up here. You would imagine the boom boom that goes off. That's why nukes are scary. Has someone stuffed a nuke in a human body? You're crazy. You're mental. You're mental. I'm scared. I'm scared, guys. You're mental. And does it with the colon capital D. So yeah. Okay. Oh, so M is greater than equal to 60. So here's your answers. You could write them different ways. Usually people like the variable in front or at first. Tell us or else the file will be you. I don't want to download this file again. 16. All right, so remember when we graphed that one rate from like way back when? So we're gonna do it again. with the ship problem, the ship game. Has someone stuffed a nuke in a dog? You are crazy. You're just disgusting. You just stuffed a nuke in a dog? No, no one has ever done that. No, no one has ever done that. Then kaboom. You forgot the A in kaboom. You forgot the A. Okay. So remember, x-axis is S, which is the number of ships we destroy in the game. And y-axis is P points. So before we graph, let's set up a little table. So you have 0 ships, we have 0 points, 1 ship, 10 points, and so on and so forth. 2 ships, 20 points, 3 ships, 30 points, because you get 10 points per ship. And let's graph it. So here's the problem again. So you have number of ships, S on the x-axis, and you get the points on the y-axis. Because remember, this is independent variable in depth, and this is dependent.
Can we nuke the ships?
You know what? That might be like a power up in the game. Sure, like you can nuke the ships. You know, they actually did that at the end of World War II. They actually did nuclear experiments on ships because we'll see its effectiveness. And what they did is they took captured ships and they also took outdated ships of the U.S. fleet. And I'm talking about the U.S. by the way. The U.S. did this. They took captured ships from enemy powers and their own ships that were outdated, and they put them out to sea, and they nuked it. They nuked them to see the effectiveness of a nuke. Why? Yeah, to see the effectiveness of a nuke. See, hey, if we ever use nukes at war, will they be effective against the Navy? And the answer is yes. It is toxic. It's not toxic, it's radioactive. Toxic is way different, obviously, if you want to be pedantic. It is radioactive, yes. Radioactivity is a thing. Fallout, you guys heard of Fallout series from Bethesda? Yes. It is time. It is time. So the USA has to move nearby states from the ship. Yeah. So basically, they tow out. You can tow other ships. They tow out the ships, like they drag them. How big is an average nuke? I have no clue. I'm not into that kind of. No, I wouldn't know. I'm not working for the military. At least I might, but I don't know for now. So yeah, the U.S. what they did, they towed ships. So you had your ship here, right? And they towed it. So they had a chain and they moved this ship over. So people are in this ship, but no one's in here. There's no one here, right? And they towed the ship out to sea and they put it at a certain location and then they just kept it there. And then they would nuke the ocean, or they would try to nuke a boat and see the effects of it on naval personnel. Because they want to see if it's good or not. And turns out, obviously, it's good. It's very good, in fact. So yeah, time to stuff a nuke in a dog. Cursed. You guys are cursed. All right, so you set up your units. I like to do increments of 5 here. You could do increments of 10 for each line, but I did 5. And your first dot would be 1, 10, like I said in the table. So if I set up the table again, 0, 1, 2, 3, 0, 10, 20, 30, 2. So the next one would be 2, 20, 3, 30, and so on and so forth, 4, 40. But the good ship has to go back to the US. Well, those ships are kind of destroyed after you nuke it. My text is cursed. Yes, indeed, it is cursed. Saga. The ship is kind of destroyed. It's kind of in the bottom of the ocean at this point. Once you nuke it, it's all kind of sunk. So it doesn't have to go back to the US. It's kind of there in the bottom of the ocean. The middle of the Pacific. I think it's called Operation. Hang on, let me look it up. It's an operation. If you look up Operation Trinity is the first nuclear test by the US. Operation Trinity. Okay, Operation Crossroads. Operation Crossroads is the one in the middle of the Pacific Ocean, the atomic bomb. So is there an ocean full of random? Yeah, there is. Yeah, the Pacific Ocean, Atlantic has it. A bunch of sunken ships. Yep. Some nukes. but the bad boat can be used for a new boat. Why would you use the bad boat for a new boat if you want the new boat to be better? You know, you could use the bad boat to learn from your mistakes, but you want to use it to create a new boat because you want to make it better. Does anyone eat molding? Dear guys, rebuild? Well, there's no point in rebuilding it. That costs too much money, and the war was just over. And add new things. That's not retrofitting. That's something else. Yeah. Kaboom. Okay. So you have your line. Let's get back to the lesson. We're almost done. You have your line, and this will graph P equals 10s would look like, right? And notice that obviously there's no negative values because you can't destroy a negative amount of ships and you can't get negative points. That's just not possible in the conditions I told you about the game. All right, so slope, y-intercept, and some other stuff, advanced. You don't need to know this stuff exactly right now, but it's pretty good to know. You'll learn it in like a year or two, so you might as well know now. So what we graphed was something called a linear equation. A linear equation is anything that's a straight line. Any equation that when you graph it makes a straight line. That's a linear equation. Okay, so the equation we just graphed, let's see. P equals 10s. So if we put y equals 10x, right? Because this is x, this is y. This is also a linear equation, right? Because it forms a straight line when you graph it out. If you make your xy table, an xy table basically says, hey, if I plug in 0 for x, what would I get for my y? 0, 0. So I plot it out, and then you just do it as you go with different values of x. You don't want to use values of y because that's a little harder to solve. You just want to plug in values of x, basically. So that's a linear equation. Linear equations always end up in the form y equals mx plus b. Okay? And you can see the correlation. Y equals 10x plus 0. That's y equals 10mx mx plus b. So y is the dependent value. X is independent value, like I said. M is the slope. So if you guys remember a little bit about slope, slope is rise divided by run. It is an indicator of how steep a line, a linear line, will be. And let's see, the bigger your slope, the more steep it is. So if you had a slope of like 0.1, your line wouldn't be very steep. It looked like that, right? It should go through this middle point right here. But if you had a slope of like 20, then it'd be pretty steep. It'd be like really steep, right? So the bigger your slope, the more steep your line is. And that makes sense because there's more rise than there's run. And if this number, if the numerator is bigger, then you have a bigger slope. And then the y-intercept, like I said, it's the value of y if x were equal to 0. So if x were 0, if I destroyed 0 ships, then you have 0 points. So y would be 0. But this is related to initial conditions. So if I bring up a empty screen, if I had, let's say, y equals 10x plus 100, let's say you started at 100 points, right? And this was 100. Your line would cut through 100 right here when x is 0. Notice how x is 0 right here at this vertical line. That's what I basically mean by y-intercept. Oh, I'm over the back screen. So yeah, y-intercept is basically where the line crosses the y-axis is your y-intercept. Plus 100. And I think that's really it. It's 5:56. I got nothing else. I told you, short lesson, pretty easy. The x-intercept is obviously where it crosses at the x-axis, and basically it's with at y was 0, because y is 0, y equals 0 is at the x-axis. Then what would x be? So you just plug it in to find the 10x plus 100. And then so your x-intercept would be -10. So this would be -10 right here. And these are pretty important to know. Later years, just know slope. You should know slope and stuff like that. But yeah, you guys are free to go. I think that's it. Yeah, on the point is crosses the y-axis. Yep. That's it. But no slope. You have to know this. Y equals mx plus b. Yes. Go ahead.
Goodbye. Thank you for the lesson.
Yep. I didn't yawn, did I? Oh my god, I didn't yawn. I'm so tired though. I don't know. What is x-intercept? So x-intercept is like y-intercept, except it's wherever the line crosses the x-axis, this horizontal line, wherever your line crosses. And or in other words, it's with a value of x when y equals 0. So like I said, if I had the equation y equals 10x plus 100, and if I wanted to find the x-intercept, I would plug in 0 for y. So 0 equals 10x plus 100. Oh, whoops. So when there is x-intercept and there's y-intercept, yes and no. Yes. Can you explain the last question? Yeah, like this question? Hold on, I'll answer your question. Yes and no. Yes, if the line is in the form y equals mx plus b, yes, you would have an x-intercept and a y-intercept. No, because not all lines, if you graph y equals x squared plus 5, it would not have an x-intercept. Instead, it would start at 5 right here. So no, only for y equals mx plus b. Can you show me y equals mx plus b? Okay. Okay, so you have y equals mx plus b, right? And this is just like a general outline of linear equations, where linear means straight line. This is general outline. So y equals x fits this general outline. M is 1 and b is 0. Well, 0. So you get y equals x. That works, right? And if you make an xy, that should be xy. If you made an xy chart or xy table, so when you make an xy table, you just put in values of x, random values of x that would suit your increments, and you just plug it in into your equation, right? So y equals x. If x was 0, y would equal 0, because y equals x. If x was -1, y is -1, and so on and so forth, right? Then you would graph each point. These are your points. Remember, x, y coordinates. These are your x, y coordinates. Exactly. These are exactly your x, y coordinates, right? So 0, 0 is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So if we graph it out, -2, go right here. -1, -1. 0, 0 is obviously right here. 1, 1, and 2, 2, right? And then you connect the line. This is a linear equation. Assume this line is straight and it goes through the points. It's hard to draw with the mouse. But this is a linear equation, y equals x, right? That is the line y equals x. That's what we say for the line y equals x. That's one example of y equals mx plus b. M is your slope, x is just x, y is y, and b is your y-intercept. Now notice that the y-intercept, it crosses the y-axis at the point 0, right? It crosses at 0, which makes sense because our b is 0 plus b. The origin, yeah. This is hard. You're only in 4th grade, okay? You don't have to notice. This is pretty, not advanced, but it is a little advanced for 4th graders. But you learn this in middle school real fast. The origin. So you can have negative y-intercepts, obviously. You have like, say it's like y equals x minus 5. Your b is -5. That's your b. You're in 5th grade? Yeah, you can go. Yeah, you can go. I'm just sticking around for questions. Yep.
Bye.
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 Have a good one, guys. Did you ever use Microsoft Clippy as a kid? Microsoft Clippy? What is that? Oh, the assistant thingy, right? Like, hey, you need help. Yeah, I used it. Yeah, it's a meme now, but yeah, I use it sometimes. I was like, what is this? What's Microsoft Clippy? It's like an assistant. I was like, hey, do you need help? Or like, hey, you need to edit this thing. I'll help you fix your spelling problems or something. It was more annoying for most people. I found it funny. I liked it. It was more annoying for most people because it was just constantly in the way. It's like, hey, you need help? Hey, you need help? Yeah, it just be like a pop-up on like the side of the screen. You just be annoying. It's Clippy, Microsoft Clippy. Look up Clippy, Clippy. Clippy. I used that as a kid, yeah. I used that. Okay, can I explain the coordinate plane and the names? Yep. Bye, Sarah. I'll see you guys tomorrow. Coordinate plane and the names. What do you mean by that? So I'll explain the coordinate plane. I don't know my name. So coordinate plane. This is called the YX or XY coordinate plane, right? Coordinate plane. It's also called the Cartesian plane because of a famous French philosopher named oh my god, whoops, René Descartes. I messed it up. René Descartes. It's got the Cartesian plane, right? So XY plane, coordinate plane, Cartesian plane, Cartesian plane. And what do you want to explain? So X is your horizontal line. This horizontal line is the X coordinates, your X plane. And Y is your vertical. And they also reference this as like a 2D plane. They call it 2D plane because it's all 2D. You can make a square with it. You can make a circle. You can make a triangle. It's all 2D stuff. It's also known as the 2D plane because you have two dimensions. You have X and Y. And then you have the advanced plane of X, Y, and Z, right? Like imagine Z was popping out at you. This is Z right here. X, Y, and Z is a 3D plane. And those involve vectors and whatnot. So obviously in the coordinate plane, if you have your points, you have your X points and your Y points. X goes first and your Y points. Quadrants, you have the quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 1 is all positive, positive. X is always positive, Y is always positive, quadrant 1. Quadrant 2, X is always negative and Y is always positive, so you're negative, positive. Quadrant 3, so negative, negative. So X is negative and Y is negative, right? Because this is your origin. And quadrant 4, X is positive and Y is negative. It's good to know because when you graph circles or you graph the unit circle and you use sine, cosine, and tangent, which I won't get into, that's T, by the way, tangent, it's good to know, hey, if you had your, that's a horrible, okay. If you had your unit circle and you know, like say, you know, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. You can find out values of sine, cosine, or tangent really fast if you knew your quadrants. So it's useful. Anything else? Let's see. Like the origin and point things. Oh yeah, so like I said, X, Y. This is a coordinate point. Coordinate point. That's a P. Coordinate point. And when you have a coordinate point in the form of y equals mx plus b, basically, if you had your x, y table, like I said, let's say 0, let's say you have y equals 10x, easiest. If I plug in 0 for x, y would equal 10 times 0, which equals 0. So your y would be 0. So that's one coordinate point in the line y equals 10x. So you have 0, 0. Remember, x goes first in a coordinate point. If x was 1, y equals 10 times 1, you would get y equals 20, or 10, sorry, 10, right? So this coordinate point is 1, 10. So I just need to notice x goes first, y goes second. And about the origin, origin is always the point 0, 0. That's always origin. I don't know what else about the origin. Usually most lines are reflected about the origin. So if I had this line and I reflect it across the x-axis about the origin, or rotate it about the origin, usually. That's what most people will say when you rotate lines. I don't know what else though. What else are we talking about? Why though? Why is y 10 times 0? Okay, so we had y equals 10x, correct? Now we can remember x is the independent value, right? Remember x-axis has your independent variable, y-axis has your dependent variable, correct? Right? So x, we can choose whatever value for x at will. We can choose whatever value at x we want because it's independent of anything. It's its own thing. We can choose whatever value. So if I chose 0 for x, right? If I chose 0 for x and I plugged it in, I plugged in 0 for x, I substituted, you would get y equals 10 times 0, which thus equals 0. So then your y would equal 0. Why? Why does 10 times 0 equal 0? I should ask that. Why is y? You can pick anything you want for your x value, correct? You can pick anything you want for your x value and just plug it in. You can put x. But why does y plus 10 times 0? Oh, this y equals. This is y equals 10 times 0. That's what I'm trying to say. Remember, a number times 0 is always 0. Even 0 times 0 is 0. There's no plus in it, if that's what you're asking, Zoe. Yes, that's what you're asking. Yep. So there's no plus. There is no plus. There's only an equals. There was an equal sign. Oh, you're talking about y equals mx plus b? Oh, okay. So y equals mx plus b, right? The b is 0 in this case because the y-intercept is 0. Because if you graphed it out, it crosses the y-axis, this horizontal line right here. It crosses the y-axis at the point x equals 0. So then thus your b is 0. That's why y equals mx plus b. And then you have compared to y equals 10x. Your m is 10. Your b is 0. Right? And that doesn't change the equation. It just tells you that your y-intercept will be 0. So it'll cut through the origin. That's what I'm trying to say. This is the point. Y equals mx plus y. At the end of the day, if you're in doubt, if you ever see an equation and they're asked to graph it, like y equals 2x plus 6, if you're ever in doubt, know that this is the y-intercept, so you can instantly plot it. So if 6 is right here, you instantly put a point here. And then if you're in doubt, just make an xy table. And then use those coordinate points to make the line. And it's always going to be a straight line. It will go from, it will cut this way if the slope is positive, so equals positive m. And it will go this way if negative m, if your slope is negative. This is not, should be straight. Like this. Like that. So y now equals y equals 10x. That's just the equation you're given based on the game. So like, let's use the game problem, right? Okay, p equals 10s, correct? Remember, p is your dependent variable. The amount of points is dependent. S is the amount of ships, it's independent. So remember, dependent variable goes on the y-axis. independent value goes on the x-axis. So you can plug in, you can say that P is y and S is x. So now you have y equals 10x. It's the same thing as this P equals 10s. That's, don't worry about the slash thingies. Okay, well, actually, you should know two different lines. Most common is if you had okay, that's not straight. Okay, let's make a straight line. Try to make it as straight as possible. Okay, pretend this went to the origin, pretend. This is the line, common line, y equals x. Always gonna cut through the origin. It's gonna look like that. It's not gonna look that steep. It's not gonna look like anything. It's gonna make a 45-degree angle with the thing, the x coordinate, or the x thingy. Why does y equal x? Oh no, there's no y to it. It's just an equation that you get, that you just graph. Say like, there's no y to it. You just say, it's just a statement you make, y equals x. And they say, hey, graph y equals x. You're like, okay, graph y equals x, it look like that. There's no y to it. It's just like, okay, y equals x. Now, if you had a situation where if everything is like to 1-to-1, so like, let's say I got 1 point for each ship I destroy, right? So your points is P equals 1 point for every ship. P equals 1s. Then you can say P equals S, which then if you put P for Y or Y for P and X for S, Y equals X. That's what that means. Y equals X means what's next? 1, the slope of 1 plus the y-intercept of 0. That's what it means. So it depends on the situation. If either it just tells you straight up, hey, just graph y equals x, then you don't have to, there's no y of y equals x. There's just the equation, you see it. Now, if it was a word problem, like say, each ship you destroy gives you 1 point, then you get P equals S, which is y equals x. Is y-intercept always 0? Yes, in y equals x. In y equals x, the y-intercept is always 0 because the b is 0. B is your y-intercept, remember? If you don't see any number, if you see like y equals 10x, y equals negative 13x, and you don't see any number right here, then B is always 0. So you know the line is going to go through the origin. Because if I just wrote plus 0, minus 0, it's the same exact thing, right? There's no difference. So y-intercept is always 0 if you don't see your mx adding something. But not always, obviously not always, because y equals, say, 5x minus 2. Negative 2 will then be your y-intercept. And then you would have to draw the line cutting through negative 2 on the y-axis. Any other questions? Okay. If no other questions, any other questions or no? If no other questions, I will just end it. I'll see you guys tomorrow. Okay. I'm gonna end it. I gotta go eat. I will see you guys tomorrow. Have a good one, guys. Take it easy. Bye-bye.